Hello, Honors Theoretical Chemistry. Today we are talking about stoichiometry. We're going to use our understanding of the balanced chemical equation to start calculating the amounts of reactant and product that are going to be used and produced in a chemical reaction. And so you can see our Wikipedia definition right here, the calculation of relative quantities of reactants and products. And so some example questions that you might have are, so for example here I've got the reaction of methane with oxygen making CO2 and water. Now after today you'll be able to say, all right, if I use 5 moles of methane, how many moles of carbon dioxide will I be able to produce? And how many moles of water will I be able to produce? Eventually we'll be able to calculate using mass quantities like grams. And so if I react 20 grams of methane with 40 grams of oxygen, how many grams of CO2 will I make? So these are the types of questions that we're going to be answering together. First of all, we've got another dimensional analysis train that we're going to be working with here. And so what you see on top are the units that we're going to be converting between. And so you can see we're going to be using mass. That'll be in grams usually. And we've got a conversion factor that we use to get from mass to moles. We've done this quite a bit. We use the molar mass as a conversion factor. We calculate that from the periodic table. Then we'll be able to convert moles to moles. This is where we're going to actually switch compounds, where we can convert from moles of one compound to moles of another. And so this is our new step, and this is what we're going to be focusing on today. And then eventually after you get that, you'll be able to convert to mass of your next product, and so on. There's even more branches to this. But this is the only step we're practicing today because it is the only new step. Okay? And so let's do a couple example problems together. We've got a chemical equation. First of all, we need to balance this chemical equation. And so we've got, looks like 1 potassium, 1 chlorine, 3 oxygens, 2 oxygens. I'm going to need an even number of oxygens over here. So let's add a 2 here. Well, now that's going to give me 6 oxygens. I'm going to need a 3 to give myself 3 times 2 is 6. And 2 potassiums, 2 chlorines. There we go. Looks like that's balanced. All right. How about our problem? Well, it says in the decomposition of potassium chlorate, how many moles of potassium chloride can be made from 34.0 moles of potassium chlorate? So our potassium chloride's decomposing into these two products. Well, let's start always with what we're given in our problem. We're converting from this many moles of potassium chloride to moles of potassium chloride. So 34.0 moles KClO3. All right. My conversion factor is going to be my mole ratio, and that's our new step here. We said that the mole ratio is the conversion factor to get from moles of A to moles of B. The mole ratio is the coefficients on the balanced chemical equation. And so KClO3 to KCl, this is 2 moles. Every 2 moles of KClO3 will react with 2 moles KCl. And I don't need a calculator for that one. It's just going to be 34.0 moles KCl. Just like always, my units cancel. Moles of KClO3 cancels moles of KClO3. Notice I put my KClO3 on the bottom because my units need to cancel diagonally. And so that's how you know where to put your, which way to orient your conversion factor. All right, let's do the next one. This one's already balanced for me. I've got my POCl3 reacting or decomposing to make phosphorus, oxygen, and chlorine. If there's no number in front of it, it's assumed that it's a 1. All right, How many moles of chlorine gas can be obtained from the decomposition of 0.350 moles POCl3? Okay, just like before, we're going to start with what we're given in the problem, and I am trying to find moles of chlorine gas. That's my question. So that's what I'm going to, that's my end goal here. So I need to get a conversion factor between POCl3 and my chlorine gas. Well, my conversion factor is 2. Every 2 moles of POCl3 will make 3 moles of Cl2. And so that's my conversion factor. Which one do I put on top and bottom? Well, I'm starting with POCl3, so that's the one that needs to cancel diagonally. 2 moles POCl3, 3 moles of Cl2. All right. Plug that into my calculator. I've got 0.350 divided by, or times 3 divided by 2. And I want to retain my number of significant figures, and so in my original problem I have decimals present. I count from left to right, the first non-zero number, and everything after, 1, 2, 3. And so I need to retain 3 sig figs. So I need 0.525 moles Cl2. Decimals present, left to right, ding, 1, 2, 3. Okay. All right. Let's do one more example, and then I'll let you try one on your own. How many moles of diatomic phosphorus? So now I'm converting to phosphorus, can be obtained in decomposition. All right, 0.350 moles POCl3. I've got my mole ratio here is going to be 2 to 1. So I've got 2 moles POCl3 and 1 mole of P2. Plug it into my calculator. 350 divided by times 1 divided by 2, 0.175. And that is moles of P2. And there you have it. So really the only new step that we're learning here is just using the mole ratio as a conversion factor. Eventually we'll be giving you amounts of in grams and asking for the resulting mass, in which case you'll be using more steps. You'll be using the molar mass to convert with that. But for now, let's just practice using this mole ratio. Try number 3 on your own, and I will see you soon. Good luck.